Today's lesson is the commutative and associative properties, day 1. So first, on your own, I would like you to complete exercises 1 through 4. Okay, so exercise 1, 2, and 3 are on your current page about Susie and Ben. Exercise 4 goes into the next page, just at the very top. And then you and I will talk about a follow-up after that. So at this time, please pause the video and try exercises 1 through 4 on your own, and then you can resume the video to discuss the answers with me or listen to the answers from me, and we will do the follow-up together. Okay, so exercise 1 said Susie draws the following picture to represent the sum 3 plus 4. Ben looks at this picture from the opposite side of the table and says, you drew 4 plus 3. Explain why Ben might interpret the picture this way. Well, that's because Ben read the picture from right to left. So Ben read the picture from right to left. So he saw the 4, then the 3. Susie's reading from left to right, so she saw the 3, then the 4. In exercise 2, Susie adds more to her picture and says the picture now represents 3 plus 4, in parentheses, then plus 2. How might Ben then interpret this picture? Explain your reasoning. So we know he's on the other side, so Ben would write, now you have to think about this from his perspective, like we know he's standing on the other side from exercise 1. He would write 2 plus 4, because he's seeing it in the opposite direction, and then plus 3. Again, we'll restate that he is seeing it from right to left. So again, seeing it from right to left. Now in exercise 3, we're moving from something that would be explained using sum to now things having to do with product. So in exercise 3, it says Susie then draws another picture that represents the product 3 times 4. Ben moves to the end of the table and says, from my new seat, your picture looks like 4 times 3. So we're gonna draw what Susie might have drawn and what we think Ben might have drawn from a different viewpoint. So 1 might draw a picture of 3 times 4 as having 3 on the top and 4 on the side. So if we draw this in a diagram, we'd have 3 going this way and then 4 going this way. Okay, which is 3 times 4, giving me a total of 12. But then another person might see the 3 on the side and the 4 on the top. Still giving me the same exact number of pieces and the same value, but seeing it in a different order. Now, exercise 4 can be a little tough to draw, so we'll do this again together, see what we think. Exercise 4 says to draw a picture to represent the quantity 3 times 4, then times 5. That could also represent the quantity 4 times 5, then times 3, when seen from a different point of view. So the big thing I need you to take away from this, and you can put a little star there, is now we're getting into 3D drawings, which just do the best you can to draw a sketch of, because we are now multiplying 3 different numbers. So think about it as the first 2 in parentheses are telling you the rectangle that you will draw. So if we look at the 3 times 4 and we draw it, say like this, we're going to make 3 this way, and then we're going to make 4 this way. So this is a 3 by a 4. But then it's going to have a depth of times 5. So trying to draw this the best we can 3D, we have 1, 2, 3, 4, 5 sections now that then we have to continue the 4 sections from before. And then you will end up with a similar type drawing on the top. So you'll kind of come back like this and like this, and you'll still continue your 5 sections, but then you'll also continue your sections of 3. So you end up with something that looks like that. So the difference there is that you're doing the 3 by 4 rectangle and then adding the depth of 5, whereas in the other one, we're making a 4 by 5. So we'll do a 4 by 5. Straighten that out a little bit. So we have 4 and then 5. So we're going to start with the 4 by 5, and then we're going to have only a depth of 3. So we would continue our depth of 3 here like this, and then we would continue our lines here to get a diagram that looks something similar to that. Okay, so as a follow-up, can the ideas from exercises 1 through 4 be applied to all types of real numbers? We're going to take some look at examples, and the answer to this is yes. And now we'll look at some examples. So we could have, and I'll try to use some more complex numbers other than just like counting numbers or whole numbers. We could take the square root of 5 and add the square root of 2. And on the other side, would we get the square root of 2 plus the square root of 5 as a result? You can take your calculator right now and test that out. Pause the video if you need to, and then resume to check your answer. Okay, the answer to that is yes. Okay, so we can have that. And here's some other examples. Think of fractions. We could have 2.5. We could do plus, let's make a difficult, just numbers, 3/19, and that would be the same as 3/19 plus 2.5. We can do it with a problem that we had up above where we have some sort of associative grouping. So let's do with some decimals. We'll do negative 6.65 plus 9.77, and then add 22, and that should be equal to, and I'll just kind of squeeze it in underneath, negative 6.65 plus, and then grouping 9.77 plus 22 together. And we can keep coming up with more examples of this. So I want to take you back and remind you of your 4 properties of arithmetic that you should be familiar with. Okay, first one is commutative property of addition. Okay, so that means if we have an order on one side, such as A plus B, we are going to switch the order on the other side. So B plus A. So the way I like to think of this is by knowing that the word commute is inside of commutative property. And if you're going to commute somewhere, I mean, granted, spelled slightly wrong, but if you're going to commute somewhere, that means you're moving. The morning commute tells you what the traffic is like. So you're just switching the order. So let's put that in the box. You're talking about order here. Okay, now I'm actually going to skip over associative property of addition for now, and I'm actually going to go fill out commutative property of multiplication, because that's going to be very similar to what we just talked about, but instead of plus signs, we're going to use multiplication. So this is still an issue of order, just with a different sign. So it'd be A times B equals B times A. Okay, now we're going to talk about associative. Associative has to do with who you associate with. Okay, so think about that as who you associate with would be your friends, your group. Okay, so I want you to remember that this is all about the grouping. So an example of the associative property of addition would be that you're going to take A plus B and add those first, then add C. But on the other side, I'm keeping the order exactly the same. Be careful of that. Order can't change, just the grouping is changing. There will be problems that will try to catch you where they'll put parentheses in there and you'll think, oh boy, it's associative. And then you'll realize they're not in the same order. So be very careful of that. Now again, associative for multiplication is the same idea, but with multiplication instead. So we would do A times B first and then multiply it by C. But on the other side, we would do A and then multiply it by B times C. Okay, now there are other additional properties from the past as well that I want to discuss with you and remind you of. Okay, we have the identity property. Okay, identity property of addition or multiplication, obviously based on the operation. And I want you to think about identity as yourself. So you get yourself back. So for addition, the identity property you want to notice is 0. If I take any number and add 0 to it, I get myself back. For multiplication, it's the number 1. If I times myself by 1, I get myself back. Okay. Next, you have the 0 property of multiplication, which just says that any number times 0 equals 0. Then you have the multiplication property of -1 or 1, which says that if you take a number and multiply it by -1, you get the opposite of the original number. And very similarly to the identity above, 6 times 1 is 6. If you multiply by 1, you get yourself back. And lastly, one that you know very well and use all the time is the distributive property. You are taking A and multiplying it by B and multiplying it by C to get AB plus AC. And that concludes your lesson on commutative and associative properties, day 1.